Hey guys, Murphy here. It's been a while really since I did a video, and I'm sorry about that. This is coupled with the fact that work has been quite hectic, and the time wasn't really there for me. Okay, but I promise to do one or two few tutorials and hopefully some video nuggets and tips and tricks. Okay. Today really I was excited by a friend of mine who actually requested that we try to set up a simple load balance lab in, using Linux, and the challenge was at the moment was I was able to implement a load balance sorry, not a load balancer really, it's a high availability cluster in the past, and that had worked well. But today I kind of played around with the load balance feature in Linux, and I must say that so far it's been interesting and a very good product. Now it has actually gone through a lot of changes. I will be installing the Red Hat cluster suite, and this is because the CentOS package or the CentOS server comes with the package pretty much installed. And majority of what we're going to be doing, we're going to be installing from the media, which is a DVD shipped with CentOS. Alright, so what I have here in terms of hardware, it's I'm running VirtualBox here. So I have 3 virtual machines. I have a cluster. This is what will load balance the traffic between the 2 web servers, and then I have these 2 web servers which will just basically run Apache. This is just to test the ability, the capability of the load balancer. Alright, so majority of what we're going to be doing will be set up based on the cluster node here, which is the load balance cluster node 01. And for a typical production environment, the recommended number of clusters you might need or you will need is about 2, and this is because you will want to provide failover between the 2 load balancers, and then that way when one load balancer fails, the other one takes over and still does the load balancing and serves requests from your servers. Alright, so with that done, let me switch over to the console here. Right now I'm logged in at logged into the load balance cluster node 01, and this is just the new CentOS basic bare metal install. This is basically for my bash class, operating system class as well, and I might be installing quite a few things. Okay, so with that said, let me reduce what I have to say and let's see how it's done. Alright, so first of all I'm going to load up the CentOS DVD ISO on the virtual machine, and this is so that I can boot or I can mount the DVD and then install the cluster group, which will contain the Red Hat based management software. Okay, come on, what's wrong? This is supposed to come on. Alright, so let me just see if this could bring it up. Alright then. Alright, so I'm just going to load the CentOS DVD. Alright, bear with me here, my system is a little bit slow because I just have 3 gigs of RAM. Okay, I'm just going to load the CentOS DVD here. Okay, and then bring up my putty. Alright, so I'm just going to mount the media inside media CD-ROM, and this I already have already. So I'm just going to run the this is going to be a local from the media, so I'm just going to disable and then enable only the C5 media. Okay, and first of all I might just want to do a group list so I see exactly what I have installed or what I have available on the DVD package. Okay, so this should run quite quickly. Alright, so create the meta file, run through and check the DVD. Alright, so here we can see I have the configuration set already. part of the available groups that I've now installed is the clustering group. Alright, so you can as well just do the group install, then clustering, and this should work. Okay, but I think alright, let me just go ahead and install the clustering group anyway. So this will install all the necessary packages. We don't have to worry about the dependencies and all. Right, so I'm going to press enter. This, depending on your system, might take a while because the clustering package might install Apache and quite a few dependencies and RPMs. Alright, so it's checking for new repos from errors. So this is basically reading from the C5 media repo. Right, so you can see it's installing the cluster sim, it's installing LOC, the IPVS or the IPVS or IP virtual server admin, the RG manager. This is then the Piranha package. This is the graphical manager that we will use later to configure the load balancer, and then some dependencies as well, like the app utils, then some Perl modules. This is for the the monitoring resource or the resource agents. Okay, so it's installed in MySQL. It has installed PHP, I think. Alright, so it has installed PHP, installing Stunel. These are all dependencies really. Okay, so it's about 68 megabytes of in size and about 61 packages, so this might take a while, but really the packages we need is the the Piranha, the basically the IPVS and the admin, and the well, there's a graphical tool that you might use, but this is not as powerful as the Piranha graphical interface that we will use. Alright, so this might take a while. I'm just going to pause the video and come back when the installation is complete. Alrighty then it has installed, and that was a whole lot of packages, but that should install the Piranha GUI. So a couple of things we need to do. We need to make sure we add it to, by the time we list the Piranha, we should find the Piranha GUI off, and then we're going to make sure that this is enabled during startup. Okay, so I'm just going to install or enable this, and then another service we need to check real quick is the Pulse service. This will be what will run when the Piranha GUI runs. This will be what will actually monitor the daemons. So we're just going to actually put this on as well. Alright, so with that said, let's start the Piranha GUI. And like I said, this is the graphical this is graphical manager created by Red Hat. This is just to ease the management of the cluster environment. Alright, so service Piranha GUI, and then start, and yes, once I do start, this should come up with an OK message. Well, this has actually started the Apache daemon. As you can see, it mounts itself to the Apache daemon, and then well, you can see here that it says the app socket address info get field for this. Alright, so we could as well just modify the server name configuration. This is default startup for CentOS, or we can just check the status real quick for. Alright, let's just do this. This should come up with some few addresses. Alright, so here we can see that the system is not listening to any. We could try the TCP. Right, so here we can see that it's listening. So Piranha usually listens on port 3626. This is a graphical interface, and you can see here it maps itself to the Apache daemon. Alright, so we want to go to system config HA, and within the HA configuration file you will see the LVS configuration file, which is the lvs.cf. Alright, so if you check the contents of this document, at the moment there's nothing. This is because we've not started writing the configuration options using the graphical interface, and at the moment we can't start the pulse service. This is because we need to create some virtual servers or populate the lvs.cf file with some configuration files. Alright, so a couple of things also we need to do as well is to enable IP forwarding, and to do that we can edit the sysconfig, alright, so the sysctl, sorry, and here we can enable IP forwarding by just changing this value to 1 and then committing the changes using the sysctl-p option. This is to avoid rebooting the machine. Okay, just refreshes the kernel and injects the new configuration, the changes. Alright, so having done that, we have the two set up. We can try to use our graphical interface to reach the Piranha GUI, and our IP address at the moment is set to 172.16.10, and this will be our management IP address for the cluster controller. Alright, so before you continue, really we want to just SSH to the other box, so I can just SSH here. Okay, this will be the web cluster 1. Okay, so here we can log in, okay, and make sure we have the Apache daemon on. Right, so here you can see that reading the service HTTPD is off. Right, so we need to mount back to our DVD. I hope this comes on. Okay, so here we're just going to mount the DVD and install the Apache daemon, as this is what we're going to run, and then load balance between the two. Alright, so services, CD DVD, and then the CentOS ISO. Okay, so alright, so here I'm just going to mount, okay, from dev DVD to our media CD-ROM. If you're doing this from scratch, you really don't have this directory, and this is because, as I said, I imported this virtual machine from one of my already existing appliances that I created. Alright, so I'm just going to install from the media. Okay, C5 media. Okay, HTTPD. This is required, so I'm just going to copy this and I have to type it again. As soon as it's done installing, I'll SSH to the second machine and then install Apache as well. Okay, so this will install all the Apache dependencies. This will be a short install. Another thing we can do really is to clone or duplicate the session here. Okay, so I can SSH as root to the node 2, accept the certificate. Okay, so here I'm going to mount the DVD again. Okay, just going to run this command again. So while it does that, I'm going to switch to the first one. This has finished the install, and then another thing I want to confirm is if I have IP tables installed. We're going to need this to redirect the traffic coming from the cluster, and as you can see, it's not installed, so I can install it the same way, just IP tables, and this should install IP tables as well. Alright, so check on the second one here. Okay, so these are the prerequisites you really need to do on your servers. You have IP tables running, and then you have the web servers as well running. That's the Apache web servers. Alright, so while we wait for that to come on, we can go ahead and start this. We can make sure the HTTPD is on and that we have HTTPD listening. HTTPD, silly me. Alright, so I'm just going to use Nano to create a file, and then this could be serving from web cluster 01. Right, so this, we can just add this just to test. Doesn't matter because the permissions just says read, and that's basically all we need to view this document over the web. Right, anything you can do if you're feeling heroic really is to change the ownership of this file. This is not required, so now it's owned by, okay, so now it's owned by Apache. Anyway, this second one should finish by now, and just like we did, we're going to install IP tables. Okay, this should be a quick install as well. Alright then, since this is complete, just going to start HTTPD on boot. I'm just going to start the HTTP daemon. Alright, so just going to create, using Nano, the index.html file. Here we can say serving from web cluster 02. This is just so that we can test from our configuration file here. So I think this is basically all we need to do here. To close the connection, we have 2 sessions already. Alright, so another thing we could do here is just to ping the servers, make sure we can reach them. So here we can ping the first web server, and then we can ping the second web server as well, which is good. Alright, so now that we've done that, we know that the IP address of the cluster controller is 16.10. So we open up a web browser, and then we type the address. Okay, so here it says Apache can't establish the connection, unable to connect. So let's see what's wrong. Service HTTP status. Alright, then here we have a culprit. Okay, service HTTPD. Anyway, what I notice is we don't really need to start the service. It starts its own special version of HTTPD. What we have missing here though is the port, because at 80 it doesn't listen to any requests. Okay, so to do this, it's going to be port 3636. Alright, then here we have it listening. Okay, so that's the difference. And this is Piranha, the HTML based cluster configuration tool. You can see this is by Red Hat, and you can as well just log in. Now at the moment we can't log in because the user doesn't have an address, so this is a step we have to do before we log in. Alright, so I'm just going to go back to this and go back to the interface here, the controller, and then run the Piranha passwd. Alright, so you can see here it says new password, so we're just going to put in the password for our cluster. Right, so you can see adding password for user Piranha. So once we have that done, we can try to log in again. This time around the user is Piranha, and the password is whatever you put when you type the password. Right, so if everything is successful, we should be on the screen here, and this is the Piranha configuration tool. As you can see, it's looking more Red Hat, and at the moment Pulse is down because the daemon is down. That's why it's reporting that it's down. And here you can see that the current LVS routing table is doesn't have anything, and the processes does not have anything. So we have to actually go ahead and start to configure this. So we start with the global settings page, and here you can see that it picks the IP address of the interface 8080 by default, and this is the primary server public IP address. So what this means is this is the IP address that will be reached publicly by the public. People will reach this to access our web servers. Alright, so now depending on the scenario and the routing technique that we employ in our environment, as you can see here, it says current type is direct. This means we are using direct routing, so we don't have to do anything like network address translation or NAT. And then we can leave this place blank because we are not really creating any NAT, so we don't need any private IP address. Alright, but if you change it to NAT, if you notice the configuration page will change, and notice here you have to specify the NAT router IP and then the subnet mask and the route device. Alright, and then of course the direct routing. Now the direct routing is okay, mostly it's default, but if you have an environment that requires you pass through a NAT before you get to your servers, then that would be the best option. It also supports tunneling, which is also another technique, but for now we're just going to stick with direct routing. So we're just going to go ahead and continue. I'm just going to leave this blank. Alright, so this is basically all we need to set up for the global settings. I click on accept here to apply the changes, and what this does is if we go back to the page, that's the graphical page, and we go back to the lvs.cf file, notice it has gone ahead and written a serial number for this, written the primary IP address, the service as LVS, Linux virtual service, the network as direct, and then of course we don't really have a debug level anyway. Alright, so as we configure this, it keeps writing to this file and the system can start. Okay, so for redundancy here, this is what I was talking about earlier. As I said, when doing in production, you will want to create a backup cluster controller so that if there's a failure with the primary cluster controller, it will fail over to the backup. Alright, so at the moment we don't have this, so I will leave this as inactive. I will jump to virtual servers. Okay, so as soon as we create a virtual server and we activate it, then we can start Pulse, and then Pulse will start monitoring the virtual servers. Alright, so at the moment we don't have any, so I'm just going to click on add, and as soon as I click add, it creates a sample entry. So I need to configure this entry as well. So I select it and I click edit. Alright, so here I'm just going to say this virtual server is going to load balance web service, so I'm going to say web servers. Okay, so the port is going to be port 80 because this is the default web servers, so but you can change it to whatever you want. The protocol is going to be TCP, okay, as for web service. Now the virtual IP address, this is very interesting because this is now the IP address that people will reach publicly so that they could reach our controller, and then on receiving this, on the controller receiving this, it's going to go ahead and then send it to the web servers and in a particular algorithm. Alright, so I'm just going to create a web server within the same subnet here, so I'm just going to say .50. Alright, so this does not exist, so what the system is going to do is going to go ahead and create a device from our existing interface 8080. It's going to prefix it with column 1, and the idea is as soon as it prefixes with a column 1, it creates a virtual interface and then maps this IP address. That way it can now participate in the routing, and then in the global settings where we have direct routing, it's going to go ahead and route the traffic. Right, so this is going to go ahead and be class C subnet. So I'm going to leave most of these things as default. As you can see here, the weighted list connections based on the weights on the servers is going to go ahead and do this connection. If we like, we can enable round robin. What round robin allows us to do is just do a round robin between the two servers in respective of the load on the servers. Alright, so I'm just going to enable the weighted list connections, and I'm going to leave the persistence and persistent network mask. Now the load monitoring tool depends on your setup. Is you can use the remote up or the remote uptime. I haven't really tried this tool, but this is what it's going to use to monitor the load on the servers and then report the servers has been overwhelmed and so on. Alright, so for now let me just disable this. I'll come back later within the video to show you the tweak I will do to the setup as well. Alright, so I'm going to click accept. Alright, so this will go ahead and write the changes. Alright, so notice it added because of the space, it added an underscore. Alright, so if I do a cat and ls, you notice my configuration file has increased. Now I have the backup as none. I have the heartbeat port as 539. I have heartbeat set to active, which is 1. The web servers, the virtual server is still not active, so this will make this will make our server not to start. Here you can see that the server is going to send a get request checking for this header, and it's going to be expecting HTTP. So when you query this in the web server Apache, mostly with this command, it will return HTTP. Right, so when using any regular expressions, the load monitor is set to none at the moment. Here we have the weighted list connection, and then we have the quiz server set to 0. Alright, so this is basically all we need under the virtual servers. So we're going to go to the real servers. This is now going to be where we set up the real servers, the web servers address. So here you can see I don't have any setup, so I'm going to click add. Okay, so here you can see the default. I'm going to edit this, and I'm going to call this web cluster 01. Okay, so I'm going to put the IP address 172.16.0. Okay, so the first one is 11. I'm just going to leave everything as it is, default. I will accept it. Okay, so make sure these systems are reachable from the machines. Okay, so I'm going to click on real servers again. I'm going to click on add. I'm going to add the second one and edit it. Okay, so this is going to be web cluster 02. Okay, it's 172.16.0.12. As I said, leave it blank or leave it default. Okay, so once this is done and I click on these two servers, we should activate them. Okay, so click on the second one and activate them. So this just activates them in the configuration file. Right, so if you really want to customize the monitor scripts, just like what I showed you here, you can see this is what the system uses to monitor the web servers Apache. Okay, if you want to create a customized script, you can put it here in the sending program, and the system will go ahead and check the text and replace it. So you can read more about that here. So treat expected string as regular expression. That is if we want the string to be a regular expression. Alright, so basically we're going to leave this as it is. This is really when you really want to create an advanced send program. Alright, so now our virtual server is still not active. If you notice, if I click on the virtual servers option here, you will notice that the interface is 5 and the protocol is TCP, the port is 80, and the virtual IP is 50. Alright, but it's set down because it's deactivated. Alright, so I'm just going to click this to activate it. So notice now it status says up, and if I go back to the control monitor or monitoring, still nothing happens here at the moment because we haven't started daemon. So I'm just going to go ahead and start the daemon service pulse start. So if everything went successful, we should have pulse starting as okay. And another thing you want to do is immediately after you start that, let's monitor this, and then you will notice that it's actually starting. You can see here it says starting pulse as server, as master. So it's going to go ahead and test the two web servers and then come back here and report the status. Alright, so I'm just going to put it on the screen just so we monitor the status. The of Pulse, because Pulse is going to go ahead and test the two servers. Alright, so here we can see Pulse running. Okay, so here Pulse is using the scheduler. The kernel has loaded the IPVS. It has registered the protocols TCP, UDP, AH, and ASP for tunnels. Basically, it has enabled the connection hash table. It has loaded IPVS. Okay, so it has started LVS client monitor, and you can see now here making the first web server available and making the second web server available, and the two of them are set to active anyway. So you can see that means our system is ready, and then you can see the monitor of the client is listening from this virtual IP to this IP, and then from this virtual IP to this IP. Alright, so another thing I want to do now is to use the IPVS admin. I'm going to use -L. This is just to help me monitor the routing algorithm here. So here you can see I have two weights. You can see the route is set to route, and you can see the two of them are actually listening on HTTP using the weighted list connection algorithm here. Alright, so basically setting this up means we've gone ahead and done quite a lot. If we return to the interface here and I click on control monitor again, notice now that it says running, and notice this is the same output we had with the IPVS admin -L, just to list the routing. And then processes, here you can see that it uses a script called nanny, a binary called nanny, to send the get information to the servers. Okay, and the servers are located at 11 and then 12. Alright, so there's a bit we need to do right now before we get this to work. At the moment, if I come to the server and I do an ifconfig, notice now that the server has gone ahead and created the virtual interface. It has assigned it the 50, and then now we have an IP address, virtual IP address at 50. Alright, so now we need to tell each client, we need to configure each client to now via IP tables receive request and redirect the request from this virtual IP. Alright, so the way we can do that is we can SSH to each machine 172.16.0.11. Okay, just going to log in here. So I'm just going to start by typing IP tables. This is before we route the traffic on the NAT table. We're just going to go ahead and enable it based on TCP protocol, and the destination is going to be the IP address of the virtual IP address. If you remember, this is 50, and then we want it to redirect. Right, so I'm just going to copy this this line here. If I save this, okay, so I'm just going to go ahead and alright, so there's a mistake anyway. Notice most of you must have seen it and say, oh my god, what's wrong with you? Anyway, so I'm just going to correct it and then type it again. Okay, so service IP table save. Okay, so just to enable it on start. Alright, so I'll go to the next host. Okay, just paste the same information here. Okay, so I'm going to save it. Okay, I'm going to make sure it starts on boot. Okay, just so we check. Alright, so we can see here it's doing the right thing. To destination 50 here, it's been redirected. Alright, so if I come to my web server here and I go to 172.16.0.50, okay, if everything goes successfully, you can see that this is serving from web cluster 02. If I refresh, you can see this is going from web cluster 01, web cluster 02, and then you can see the load balancer working as it should. So ladies and gentlemen, if you've followed me up to this part, it means we've set up the web cluster environment, and if you like, you can go ahead and become fancy and add the virtual IP give it a domain name, and you can just have one universal domain name, and it will be serving contents from both web servers. So you can have n number of web servers, and of course I'm gonna go ahead and come later with another video, and this video is just going to show you how we can set up the backup node cluster in this our current infrastructure, and we're going to go ahead and test the load monitor script and see if that works as well. But before I end the video, really, let me just quickly, so while I'm on node 2, let me just shut down the HTTPD server and this, which is serving from web cluster 02. Alright, so if I refresh the page, okay, notice all the requests keeps coming from web 01, and this is because the system has found that the web cluster 01 is down and continues to start from the first one. Okay, so as soon as the cluster comes on, the node comes on, sorry, the system, using its timeout, is going to recalculate, and as soon as the service is up, the system will go ahead and serve from the 2 web servers. Okay, so just a moment here. Alright, so you can see now serving from 02. Okay, so you can see the traffic going 01, 02. Okay, so 01, 02, 01, 02, and so on. Okay, so depending on the monitoring stuff, if you have a web-based, if you have the round robin method, it's going to alternate between the 2 servers as well. Alright, so I hope you enjoyed this video, and basically I'm going to keep this video as a documentation purposes, so later we can go ahead and you can always go back to it and improve it. And as I promised, I'm going back with a video to set up the, probably maybe play around with the NAT and the tunneling option, and then enable redundancy within the controllers as well. Alright, so thanks for watching, and have a great day. Thank you.